Histograms. Example 3. We're given a histogram. We have the frequency density values and our data values at these key points here. We have to work out the mean and standard deviation for this data. So we start off by creating a grouped frequency table for this data. From that table we can use the calculator's statistical functions and we can work out the mean and standard deviation. So class intervals. So here's one class interval, here's another one, here's another one. Class width based on the class intervals. Frequency density, we just read off the values here. So 2, and then that one's 3, and this one is a half. The midpoint of these intervals, and then to work out the frequency of each of these bars. Frequency is frequency density times class width. So we just multiply these in pairs to get the values here. Now this is the only part of the table that we need. We put the data into our calculator and we get the mean and the standard deviation. A combination of this data in the table and linear interpolation can lead to estimates of any of these. Example 4. So we have to use the histogram to work out the number of runners who took between 78.5 and 90.5 minutes to complete the fun run. Now again, we know that area is proportional to frequency on a histogram. The total area represents the total frequency, which is 140 runners, and I've calculated the area of each bar. So you've got the width. So for example here, the width along here is 5 times the height 2. So that's the area of this particular bar. Do that with all the others, then add up the total area, which is 70. So that's the total area, and we know that it represents that frequency. So we times 2. The multiplier is times 2 to get from the area to the total frequency. So now we work out the area of this bar, which we have already done, 6 squared units. We need to multiply by 2 to go from the area to the frequency. So we multiply this area by 2, which means there are 12 runners represented by this particular bar on the histogram.